This appendix helps in understanding graphs, curves, and slopes as they relate to economics. It demonstrates how relationships between variables can be examined and how an equation that expresses that relationship can be derived. The two-dimensional graphs used in this textbook consist of a horizontal axis and a vertical axis. The point where the two meet is called the origin. As one moves away from the origin, either up or to the right, the plotted values increase. Often the independent variable, which is the variable that changes first, is placed on the horizontal axis, and the dependent variable, which is the variable that changes in response to the first variable changing, is placed on the vertical axis. However, in economics, it is customary to always place price or cost data on the vertical axis, even if it is the independent variable. Economists invoke the ceteris paribus, or sometimes called the caeteris paribus assumption in economics, in order to be able to analyze just the two variables that are labeled on the axis. Ceteris paribus means to hold other things equal or constant, and assumes that the only changes in the model are brought about by the dependent variable changing in response to the change in the independent variable. Direct or positive relationships occur as the two variables change in the same direction. In other words, when the independent variable increases or decreases, the dependent variable also increases or decreases. This graphs as an upsloping line. Each pair of values in the table represents one point on the graph. This data represents variables that are positively or directly related, such as income and consumption, which will graph as an upsloping line. Inverse or negative relationships are those where the two variables move in opposite directions. So when the independent variable increases or decreases, the dependent variable decreases or increases. An inverse relationship graphs as a downsloping line. Each pair of values in the table represents one point on the graph. This data represents variables that are negatively or inversely related, such as ticket price and attendance at basketball games, which will graph as a downward sloping line. The slope of a line can vary based on the units that are used to measure the slope. In the ticket price and attendance example, if the number 4,000 had been used instead of 4 on the horizontal change, the slope would have been negative 0.0025 instead of negative 2.5. Slope is also important in economics when analyzing marginal changes. In the income example, a slope of 0.5 means an increase of $1 in income will result in a 50-cent increase in consumption spending. If there is no relationship between the two variables, the line will graph as a vertical line parallel to the vertical axis, which reflects an infinite slope, or it will graph as a horizontal line that is parallel to the horizontal axis, which would exhibit a slope of 0. The vertical intercept is the point where the line meets the vertical axis. As the independent variable income increases, the dependent variable consumption increases. This results in a positive slope line. As the independent variable ticket price increases, attendance decreases. Here the variables are moving in opposite directions, illustrating a negative slope. Note, though generally the independent variable is placed on the horizontal axis, when price is one of the variables, in economics it is customary to always place it on the vertical axis. The graphs above show that the variables are unrelated. No matter what the price of bananas might be, the number of watches purchased remains the same. This is because the price of bananas does not affect the number of watches purchased. There is no relationship between consumption and the divorce rate. Consumption remains the same, no matter how high or low the divorce rate is. This is the general equation of a line and expresses the relationship between the two variables y and x. If you know the slope and the vertical intercept, you can solve for y or x. We calculated the slope of this line earlier, and we found that the slope is positive 0.5. We can see from the graph that the vertical intercept is 50. Therefore, the equation of this line is y, or income, equals 50, vertical intercept, plus 0.5c, where 0.5 is the slope and c is the consumption. We calculated the slope of this line earlier, and we found that the slope is negative 2.5. We can see from the graph that the vertical intercept is 50. Therefore, the equation of this line is P, price, equals 50, vertical intercept, minus 2.5Q, where negative 2.5 is the slope and Q is the quantity. In this case, the slope is being subtracted because the slope is negative. When calculating the slope of a nonlinear curve, the slope is always changing. This means the slope will be different at every point on the curve. In this case, to find the slope, you must draw a line tangent to the curve and calculate the slope of the line by finding the change between 2 points along the tangent line. The slopes of a nonlinear curve will change along the curve. Here, the slope at these 2 points on the curve will be different from each other. To find the slope of a nonlinear curve, draw a straight line tangent to the curve and find the slope of that line by dividing the vertical change by the horizontal change of that line.